Hey guys, I'm Sean from MetMo, and today we're going to be looking at the MetMo gear train. This is the first fidget toy from MetMo that's actually a puzzle as well. So first of all, let me show you what it actually is. So this is a stack of 15 gears, and they have a 2-to-1 ratio across the entire stack. So if you see all the way down here, there's some internal gear there. There's a 28 tooth all the way down to a 14, and that just creates a really simple 2-to-1 ratio that just takes it all the way through. So if you turn this gear, you'll see that gear goes at half the speed. And then this third gear in will go at half the speed of that one. This next one, half the speed of this one. And you kind of get the drift. So after all of this, all the way through the gear stack, so this final gear will take 16,384 revolutions of this first gear to complete a full revolution. And what that actually means is that this tiny hole in the top, it's on each and every gear all the way down this side. So when you first get your gear train, it will be supplied like this. And you'll see there's a handy little pin in there which aligns all of these gears. And when I take it out, then the gears are free to rotate. But I won't do that just yet because it takes 16,384 revolutions to get back to the start again. But that takes roughly around 4 to 5 hours if you were to just sit there and just do this, which is quite satisfying, but also it's 4 to 5 hours. So before we get into the puzzle aspect, because of how this gear ratio is set up, this top gear is really easy to move. And then as you get further down the gear stack, there's more and more resistance. So this third one, I now need 2 fingers to turn it. The fourth one down, definitely need 2 fingers to turn that. But as you can see, if I move it up to the camera, this gear is moving so much faster than this gear. So instead of amplifying the torque, it is actually turning that torque into much higher revolutions. It's kind of like a handheld gearbox, really. And what's fun as well is the tactile feedback you get as you move down the gear stack. It's really satisfying. And I think my fingers allow me to get to the 1, 2, 3, 4, the 5th stage before it becomes quite difficult to do. And beyond that, I have no chance. So here's the challenge. How low down the gear stack can you go? So let's go back to the second challenge of this fidget puzzle. I mentioned earlier there was a grenade pin in the top here. And what that does is the holes that I mentioned earlier, they're perfectly aligned in this gear stack. If I remove this pin, that's absolutely free to move now. So if I move it 1 finger's turn revolution on the third gear down on this side, all of these holes will be out of alignment. So let me show that again. If we just have the gear there, I will do 1 turn of this gear, and you can see them all going out of line. I then reverse it, and we're back in line again. And then I can just pop the pin all the way back in, and the gear train is completely reset. Now, if I was to go crazy with that and start doing this, that would quickly throw out the alignment, and you will be into a solid 4-hour session of resetting that gear train. So the material choices of gear train. We've gone for a solid stainless steel gear train. So that has a stainless steel base, and every single gear stage in this is solid stainless steel. Even the pins down the center, all stainless. So if you truly want a bomb-proof gear train, you want to go for this guy. The other option is to go for a lighter weight brass and aluminium combo. So the aluminium is hard anodized. It's what we use for the majority of our products. It's extremely wear resistant, but nice and lightweight. And on the bottom, we've got the nice MetMo logo. So if you want to go for a bit of more of a lightweight option, but it's still exactly the same function as this stainless steel one, I'd go for the brass one. So machining wise, these products are machined on a gear hob. It uses a specialist machine to machine each stage of these, and then they are assembled using press fit to assemble the 28 tooth gear with the 14 tooth gear, and that creates a gear stage. And each one of these is a gear stage, 15 in total, that add up to the entire gear train. The base itself is milled on a CNC machine, and the two shafts that hold everything together are done on a Swiss CNC machine. So the gears themselves are actually quite special because we've put a few more operations into this one. So we've made sure that the edges of the gears are really smooth. So when you touch them with your finger, you get a really nice tactile feedback from them. And there's no sharp edges, it's just really smooth and just kind of falls off. So you might be wondering, why have we done this? Quite a few years ago now, we saw an exhibition that's currently in MIT from Arthur Ganson. And he's an artist, and he made an installation called Beholding the Big Bang. And what that was essentially a gear train, much like this, but the end of it was set in concrete. And the demonstration was turning the start gear it just had a motor attached to it, turning just at a decent RPM, and this other gear mounted in the concrete just does not move at all. So the actual reduction was 13.6 billion, I believe, to represent when the Big Bang was. Fact check, please.
13.7.
No! It's actually 13.7. Oops. Like all MetMo products, gear train is completely serviceable. So these two rods that hold it together, they just pop out, and you can take off each gear stage. If you need to clean it, re-oil it, anything at all, that's completely serviceable. And also, like all MetMo products, they come with a 200-year guarantee. So in terms of what it actually does, if you're just sat on your desk, you can just move each stage one after the other. You can set it down, gently rotate it. I really like working my way down the gear stack because you get a really nice tactile feedback as you move down, and then back up to the top. If you have any questions about Gear Train, head on over to Cube Club or send us an email at hello@metmocube.com. Burp, burp.